Hi guys, Mr. Duke going over section 5.1 and 5.2 review on Edge Elastic. Welcome to my back porch. This is where I'm hanging out, doing some math, we all want to do on a Sunday night. Anyway, let's talk about this particular assignment. Some of you did it last week, and some of the scores were pretty good, and a couple were So what I did is, if you submitted it, I went ahead and sent it back to you, just so you get another shot at it. Even if you did okay, getting a 10 out of 10 is a little bit better than an 8 out of 10. And some of you did get 8 out of 10. It's pretty good. But I want to go over the questions, especially some of the harder ones, rather quickly with you. So here we go. Number one here, a system of two linear equations is graphed on a coordinate plane. If the system of equations has infinitely many solutions, which statement must be true? Okay, a system of equations is two or more equations that have the same variables and end up on the same coordinate plane. So they're kind of related. All right. And it can be one of three things. It can be an equation that has one solution, which is going to have a different y-intercept, or it could have the same y-intercept, but different slopes, possibly different y-intercept, and it's going to meet in one place on the grid. It can have no solutions, where they'll have different slopes, different y-intercepts, and the lines will never touch when you graph them out. Or it can be infinitely many solutions when every ordered pair works. That means it has the exact same, and keep in mind on this one because it'll help you in the next question too. It has the exact same slope and the exact same y-intercept. When that happens on a line or an equation, you're going to have infinitely many solutions. All right, let's go to the next question. All right, so looking at question 2 here. How many solutions does the system of equations below have? Y equals negative 6x minus 7. Y equals negative 6x minus 7. Okay, so it has the same slope, same y-intercept. Which one of the three is that going to be? Infinitely many, one, or no solutions? 3. The population growth of two towns over a period of 5 years is represented by the system of equations below, both algebraically and graphically. All right, what they want is they want the ordered pair that is the solution to this system of equations. Now, the cool thing is, if you have it graphically, the equations don't matter. I mean, it's cool if you can do it that way, but if you've got the graph, you need one ordered pair that the solution to the systems will be. And the solution to the systems is going to be where the two lines meet. All right, so we've got this line coming up and this line coming up, and they're going to meet right there. Whatever the coordinates of that point is, that's going to be your ordered pair. That's the solution. So it's going to be like x equals 4, y equals 10. Okay, notice the solution is both an x and a y. Okay, remember that as we get up further down the road. Okay, number 4 is probably the hardest question on this assignment. This is a state test type question. I think I borrowed this one actually from North Carolina. What they're doing here is they want the solution, which is going to be an ordered pair, like we talked about in the last question, to the system of equations below. Okay, we're going to use the substitution method here, which means we're going to put something in for a variable. The problem is, in the first equation, I really don't know what the variables are. So what I'm going to do, rather than trial and error, because I could use true substitution and put x equals 2 into both equations and y equals negative 2 and it works, that's going to take forever. Okay, it's going to take a very long time, and it's not the most efficient way to do it. So what I'm going to do is I want to solve for one of those variables. And traditionally, we solve for y. So I'm going to do that. I'm going to take the second equation up here on my whiteboard. We got 2x minus 4y is equal to negative 8. All right, what I want to do is I want to get that y by itself. Okay, so I've got to, draw your line, do all that stuff that you guys love to do. I'm going to go ahead and subtract 2x from both sides. All right, when I do that, my 2x's over here cancel. I've got negative 8 minus 2x. All right, so I've got negative 4y. Okay, to get rid of that negative 4, I'm going to divide both sides by negative 4. All right, here's the tricky part. When you do that, you got to divide both of these by the negative 4. So I've got negative 8 divided by negative 4, which is 2. Negative 2x divided by negative 4 is going to be a plus 1/2 x. All right, now I've solved for a variable. All right, you can't really see it real well on the camera there. There we go. All right, I've got y equals 2 plus 1/2 x. Now that I know what y is, I can go back and put it into the original equation. All right, so I'll go ahead and erase this out. All right, I'm going to go back to my 2x minus 4y is equal to negative 8. All right, so y was equal to, and we'll go here, 2x minus 4 times negative 2 plus 1/2 x. And it's still going to be equal to negative 8. All I did is where I solved for y in the first one, I just put it where y goes. Okay, and that's what I'm left with. All right, distributive property, I take what's outside the parentheses, multiply it to everything inside the parentheses. So I get my 4 times negative 2, which is negative 8. And I get my, actually it's a negative 4, so that'd be a positive 8. Negative 4 times plus 1/2 x is going to give me a negative 2x. So I got negative 2x plus 8 minus 2x. Combining like terms here, I get negative 4x plus 8. All that's going to be equal to negative 8. Subtract 8 from both sides. I get a negative 16. Negative 4x equals negative 16. Divide both sides by negative 4. You're left with x equals 4. You've got enough information to solve right there, all right, because there's only one choice there where x equals 4. All right, so good luck. I'll see you on the next question. Okay, question 5 here. Graph the system of equations on the grid below and then mark their point of intersection on point C. We've got y equals 3x plus 3, y equals x plus 5. Cool thing, those are both in slope-intercept form. So what we'll be able to do is we'll be able to take line A, and we'll go ahead and put that right there at 3x plus 3. So I'm going to go ahead and put my y-intercept at 3. My slope is 3, so I go up 3 over 1, because the slope's 3 over 1. That's line A. That's simple. All right, line B, x plus 5. All right, so 5 is my y-intercept. I'll go up to 5. All right, and my slope then is just going to be up 1 over 1. There's my line. All right, point C is going to be where they intersect. So I'm going to go ahead and put that right there. That's it. There's your solution. The solution of this particular equation is 1/6. All right, question 6. Solve the system of equations using the substitution method. This is kind of what I showed you back on number 4. Okay, so what we got is we got y equals 2. All right, and we got 2x plus y equals 8. All right, cool thing with substitution method. All you're going to do, you know y equals 2. It tells you y equals 2. All right, so whatever you get here, the second number in your ordered pair is going to be 2. But the other part is, wherever in this second equation you see a y, you're going to replace it with 2, because y is equal to 2. So I can just put this together as 2x plus 2 equals 8. You all know how to solve that. All right, I subtract 2 from both sides. I've got 2x is equal to 6. Divide both sides by 2, and I'm left with x is equal to, you tell me. All right, on to number 7. Okay, reading a graph. This one we struggled with a little bit. All right, because our graph originally shows the ascent or rise and descent fall of 2 different airplanes in the vicinity of the city airport. Okay, so I've got plane A is going up, plane B is coming down. All right, so what is the initial height of plane A? Plane A is going to be this line right here. And the initial height is just the y-intercept. It's the starting point. So it's going to be blank miles, where the cursor is pointing. Okay, the height of plane B after 40 seconds. So I'm going to come over here to 40 seconds on the chart, and I'm going to go up to where plane B is at that 40 seconds. So there we go. How high is plane B at 40 seconds? All right, the third one is at what time are the planes flying at exactly the same height? Okay, well, I'm going to look at where the 2 lines intersect because they're going to be at the same height. All right, so that's going to be at 3 miles, which they're going to be at how many seconds? You tell me. I'm going to go ahead and skip questions 8 and 9, and and we'll go ahead to question 10. They're all the same, so I'll just go over one of them and you kind of work it out yourself. But if I'm looking here on question 10, graph the following system of equations and mark the point of intersection if it exists. I'm not giving you the fact that it's going to intersect. All right, so line A is going to be my first function there. So I got y equals x plus 3. Okay, if you remember slope-intercept, y equals mx plus b. There's no m, so m is 1. And my y-intercept is 3. So I'm going to start line A right here at 3. And then I'm going to go up 1 over 1 for the slope. There's my line. All right, for B, y equals 2. Uh-oh, where's the x? The x is 0. Okay, there is no x. All right, so y equals 2. Okay, well, y equals 2 is going to be everything on the line y equals 2. All right, so this whole line, all right, remember, y equals 2 means that thing goes all the way across. All right, and my point of intersection, or point C, is going to be right there, right where they meet. All right, that's it for this one, guys. Good luck, good week. Really missed you guys, but hang in there. We'll get through this together. And if you have any questions, a reminder, I'm available for tutoring from 10 to 12 on Zoom every day. The link is in the Google Classroom. So have a good week, guys. If you need anything, let me know. Good luck, and I hope to see you soon.